So, good evening, everyone. I hope you all can see my screen and I'm audible.
Yes, sir.
Okay, thank you. So we'll wait for 7:05 to people may join, then we'll start. Till then, if you have any queries or questions, you can ask me. This would be at the final class for this problem solving session. If you
Sir,
have any
tomorrow
other doubts,
tomorrow is also
yes.
there is a na?
Tomorrow is a 1 hour session that will be majorly a doubt class. If you have any doubts, then I'm clear. I don't have anything to teach tomorrow.
Sir, one doubt is there in assignment 3.
Okay.
Assignment 3, question number 5.
Assignment 3, question number 5. What is the question?
A company invested 2 lakhs in a project with a life of 10 years and a discount rate of 8%. Calculate the capital recovery factor of the project.
So what's the problem in this?
The calculations is not coming out as you described, sir. Can you explain that calculation, sir, once again?
So you're asking me about week 3.
Sir, how it is come, sir? It is the CRF.
Yes, CRF is simple. Let me just check the question first. Yes, assignment 3. Which question? Yeah. What is the question number?
Question number 5, sir. When you put down the
Question number
data
5.
in the formula, that is how it is coming, sir. Because you have described there,
Okay.
but
The 10 years
one,
is there. 8% is there. Is
sir.
problem.
So, what is the calculation for 1.08 to the power 10? What is the value of 1.08 to the power 10, sir? You just calculate that. In
Let
right,
me
it is writing down that 17.487. But in calculator, it is not. How it 17.487 is coming? That is the question.
Okay, wait. So you're talking about this question,
Yes, yes,
correct?
yes.
Yes. So currently, if you are just put 0.1.08 to the power 10, then it should be
Sir.
2.15, correct?
2.15. Yes, sir.
Or it should be 2.1589, correct? And
89.
similarly,
Yes.
this would be
1.189.
1.1589.
Yes,
Then
yes.
it would be equal to 0.08. This could be 0.1727. And this could be same.
1 point.
Then it should come around
0.14 something.
0.149, correct? So
But
as you
in
raised that query, I think that last date has gone.
yes,
For
sir.
yeah.
We have deducted that number, sir,
Okay. Then it should be the right answer should be 0.149
because
according to the
the and with the related to this question also is question number 9 also you have putting down the same value for CRF, and this comes
correct.
it is an entire the answer is become totally different.
Yes, maybe. Because all these questions are related. So if you raise this query, I think you got the marks, but be prepared that if you have had the calculation must be proper in your end exams. Like whatever that you have shown, and I have shown it right now, it is the correct method. That may be that there's something typing mistakes must have done by the TA. So that would be your full marks will be given in that case, even in the final exam.
And one more questions in question in question probabilities um, 2 assessment number 2, that Fukushima plant was also not clarified from your end also, because by going through that
So
picture, it is saying that after the Fukushima disaster plant, the Japan reduces its nuclear power generation drastically, and just
hmm,
now they are in 2024 only they are again started the nuclear power. So it is that in question and in your answer you are saying that it is true. I already raised the question in previous session also. This is also a question we have answered, but I'm answering that is false. But your answer is true. So
okay,
whether
so what I'll suggest you compile all these question. We will cover that in the tomorrow's class because that will be doubt session. I have
okay, sir.
something to teach today. Then I will, if the time left, I will clear your doubts in the end of the
Okay,
class.
okay,
Okay.
thank you. Okay.
Okay. So I think it's 7:10. We can start the today's session. If there is any doubt, we can take the end of the class. Let me just share it. So good evening, everyone. My name is Sandeep Yadav. I'm a Prime Minister's Research Fellow at the Department of Energy Science and Engineering, IIT Bombay. Today, I'm taking the 12th week of this weekly live problem solving session on the subject HS24, Energy, Resource Economics and Environment. In today's week, today's class, we will cover the energy policy examples, practical problem solutions, and the few future and systems. I will also add few policies by the government and how the policies are made, how they are implemented with the example of few recent policies. So before starting, I will just go through the previous week's quiz first, then we will start with this week's content. Sorry. So yes, previous weeks we have covered this thing. Like question number one is, which of the following policies is not related to the energy access? First is a Kutir Yojana, PM Har Ghar Sahaj Yojana, Ujjwala Yojana, and the Griha Yojana. Yojana is not related to the energy access. It is related to the building energy codes. You can see energy access is related to from providing clean cooking like Ujjwala, electrification like Kutir Yojana, Sahaj Yojana. Griha is a rating tool for the building energy systems. So that will not be a part of this. I hope this is clear because this is very basic. Question number two, as we increase the number of energy services, the price of energy technologies increases or decreases. As we increase the number of energy services, the price of energy technology decreases. So that statement will be false.
Sir, how it is decreases, sir?
This means I have to go through that slides. If you need details, you can go through this. This if
Achha.
not, then you can come back to me.
Okay.
Okay. And question number three, which of the following are the energy goals specified by the Global Energy Assessment? First is increases access, enhance energy security, reduces environment and human health impact. Option number D is A and B only, like increases access. So the all of the above will be the right answer because the energy goals specified by the Global Energy Assessment are to increase the access of energy, enhance the energy security, reduce the environmental and human health impact. So that would be all of the above. Question number four is the resistance of a policy to external factors such as any change in the environmental or political condition. It is reflected by which criteria? So it is as I've explained, a policy is said to be robust only if the outcome of the policy remains same despite of the changes in the external factor. This is called policy robustness. Robust means how whatever will be the situation or there will be some political changes or like if you will see we'll study today like 1973 oil embargo case where there is no policy related to the energy till then. When it things happen that there's a need of what is the should be the policy related to the energy, then after that people are more conscious about the energy policies. Now, moving to the question number five, India's INDC commitment to reducing the carbon intensity of GDP by 33 to 35% of 2005 to 2030 level. This can be achieved by reducing the carbon intensity of energy sector, correct? Reducing the energy intensity of the GDP, change the structure of the economy, and all of the above. So I think I have explained this question in the class also. So carbon intensity of the energy reflect to the equivalent carbon emissions per energy generated, and energy intensity of the GDP refers to the energy consumed for every GDP. So reducing carbon intensity and the energy intensity reduces the emissions. Therefore, carbon intensity of the GDP also changes. Due to the shift on economy, energy intensive industry sector to less energy intensive services sector can also reduce emissions and therefore reduce the carbon intensity of the GDP. So the options will be all the three would be the goals for the India's INDC commitment. Question number six: what is the policy is the ability to achieve the goal that was not set in the policy. It's called effectiveness. Effectiveness implies to the policy's ability to achieve the goal that was set. I hope till question number six you are clear. If you have any doubts, you can ask me. Moving to the question number seven. When a production subsidy is provided on the fuel, the environmental damage will increase because the demand of the fuel will increase and the emission will also increase. I think we covered in the class. And question number 8, which of the following comes under the sustainability analysis? All of the above: life cycle analysis, thermodynamic, and economic. This is all the part of the concept of sustainability analysis of any process, product, technology that involves all of this analysis. Question number 9 and 10, these are the linked question. So we have solved this type of question in the class. So let's do it one more time. Like mica industry has an annual production of 2,200 tons. Production capacity is given, and the cumulative energy demand, that is CED. CED is given 15 megajoule per kg. Now we have to find what is the total energy consumed over the entire lifetime of 30 years. So CED is equal to total energy input of the process for the lifetime divided by the life into annual production. So whatever the things we have given the total energy for the uh, total energy given for the 15 megajoule per kg. So we know the production annual production is 200 tons. So we have to multiply by that. To convert the ton into kg, we will multiply by 10 to the power 3, and we know the lifetime, so 30. So total energy input we can calculate 15 into 30 into 200 into 10 to the power 3. That will be that will be equal to 90,000 into 10 to the power 3. That is 90 terajoules. That's how we'll calculate, because CED is also given here 15. Now, question number 10. For the question above, find the carbon emission factors. Similarly, carbon emission factor we can calculate by total emissions of its lifetime divided by the life into annual production. So 2400 is given, like for total emissions in the tons. We will convert it into the kgs by multiply times per 3. Then total life is given 30 years in the previous question, and emission annual production was also given.
Sir, one
So
question is there, sir.
Yes.
Sir,
I think that should be 200. Yeah, there's a 150 related, I guess. That is the question.
Yes, no, number 10, sir. This question, sir, after calculating that equation, I mean, the solutions, the CF is coming at 0.4, sir, but there is no 0.4.
So 0.4, you can choose the nearest option. I think also there's the one problem. So 0.5 it will be still right.
So we can't take it lower side. It will be always a higher side. If this type of question.
This type of question will this type of mistakes will not be there in the final exam, because there will be going through the thorough analysis. I think there's some slight changes in the questions if you will convert that 150 is written instead of 200. So if that would be the case, yeah. So in that case, you can choose the nearest answer. Otherwise, you can tame the.
So 2400 by 6000. It is coming 0.4, but there is no 0.4.
Correct.
In class, you said the nearest is 0.2 or 0.5. That's why I'm confused, and I put it down as 0.2.
No, nearest would be 0.53 if you will calculate, like 0.4 if you are saying, if this is coming as 0.4, what would be the nearest of this, 0.53 or 0.2?
0.2.
0.53. 0.53, correct.
0.53. That's why it is 0.53. Nearest.
So if you have any other doubt related to this quiz, you can ask me. Otherwise, we'll move ahead. So let's briefly cover the previous week's content before starting. So this week's is about energy policy examples, in which Sir has covered the comparison of different motor. What is the benefit of energy efficiency? If you see the initial cost of any equipment will be higher, then it annual electricity cost that will be provided, it will be less. And always it would be more efficient to use. As generally people don't consider, like if you will see the star rated equipments, if you consider a 5-star rated refrigerator or the air conditioner, and if you will find its cost around 45K or 45,000, and you will consider a 3-star or 2-star air conditioner, it comes out to be around 25 to 30,000. Then you will find the annual electricity cost. So annual electricity cost will be less than the 5-star AC. So its overall life cycle cost will always be less. So in that case, you should always consider the high star rated equipment if you're considering the electricity bills associated with that. Even you can calculate it any of the equipment that you are using in your home, like for the it could be a refrigerator, it could be a fan, and you can easily say what should be the you should invest in which of the equipment. Similarly, in that case, it has compared the incident lamp and the CFL and between the motor and the energy efficient motor. So this is has been a case compared. Now the other thing is minimum and so this is a PAT, perform, achieve, and trade. This is a policy introduced by the BEE. So I will explain that in the detail in my slides. So I will not go through this in this time. Now, these are all the things are already covered. So data requirement and verification, like case studies, BEEE, BLC scheme. So this energy efficiency and all the things have covered separately through the updated sheets of M1. So yeah, coming to the nuclear power plant is facing a difficult situation about the public acceptance because of the safety risk of the fuel cycle of the power plant and the nuclear waste disposal, because they're having a high level of radiations and proliferation of the weapon or the missile materials and the climate changes. So that has been people are not accepting because of these two events that has happened, like Fukushima disaster in the Japan and the Chernobyl, that is having an impact of around 450 billion euros of the damage. Also, there are other small things that has been damaged by like covered in the Belgium, Finland, and other sources. So if you will see the levelized cost of electricity in the 2030 of the different electricity generation technology, you will see, like if you see the capital cost like dollar per kilowatt of electricity, that would be least in the gas combined cycle gas power plant, and highest would be in the nuclear plant, and the O&M cost will be least in the solar PV. Fuel cost will be zero, and the solar PV highest will be in the natural gas cycle, and waste will be all the process will be nearly zero, only the coal and the nuclear. And the final cost, if you see, the highest will be in the nuclear, but it's the cleanest fuel because it doesn't have any emissions, but it's have the other emissions like radiations. So this is the trade-off you have to do, but uh, this is all the generated cost in the year 2030 that is done by the studies of Thomas B in 2012. Now these are the nuclear liabilities. Operators shall have a right of recourse when the nuclear incident has resulted in the consequence of an act of supplier or his employee, which include the supply of equipment, material with the patent or the latent defects or substandard services. There has been a few deals have signed between Indo-US and having issued insurance cover of 1,500 crores. So there are the two power plants of the new nuclear power plants established in India. Like one is in the Kodaikullam of 2,000 megawatt, and the one is the Jetapur, that is 9,900 megawatt in the Ratnagiri district of Maharashtra. So moving ahead, these are all the things are covered. Now, I think you have gone through these revision papers. You should must see these slides because this type of question you should accept in the final exams. So these two revisions paper, like I think lecture number 54 and 55, you should cover before going to the exams. I'm not going to cover this because it's already covered by the sir. Now there are a few future analysis systems that has been done. So I've added my few slides regarding this. This is the energy. This is the EIS slides uh, covered by the sir. If you want more explanation, you can go through this lecture videos by the sir. So we'll come back to these slides whenever we require them and solving the question quiz for the questions. So if you have any doubt, you can ask. Otherwise, we'll start solving this week's short questions. Yes, you can start reading the question till then I load the question paper. First question is about the according to the different targets set under the PAT scheme, the efficient plants had a dash target compared to the similar plants which are more efficient. What should be? It should be higher, it should be lower, or it should be same. And even
So it should be lower for efficient
it could
plant,
be
lower.
according to the different standards, different targets set for the PAT scheme. The efficient plant had a higher target or the lower target.
Inefficient. Efficient should be lower, sir.
Efficient plant having a higher targets
Efficient plant have a higher.
because it encourages energy efficiency in that case. Fat is nothing about the, it's more related to the energy efficiency, promotion of energy efficiency into the different industries.
Efficient.
Okay. So according to it should be higher because higher targets means if the targets will be higher, this will to encourage e- energy efficiency. Is it clear? Now, question number two. Which of the following measure have been considered in the sustainable development scenario in WEO? First one is energy efficiency. Second one is shifting to renewable energy sources. C is the fuel switch to and carbon capture. And D is the all of the above.
It is all of the above.
Correct. It should be all of the above. Because in the WEO World Energy, I think WEO stands for, check. World Energy Outlook. It stands for World Energy Outlook, and it has considered few sustainable development goals. We can also call SDS. Uh, so this includes energy efficiency, shifting to renewable energy sources, and fuel switch and carbon capture. So right option will be all of the above. Moving to the question number three. Carbon CO2 emissions per kilometer traveled on an average for electric vehicles currently in India is higher than the that of IC engine. Is it true or false? It's an interesting question. Which one emit more CO2 emissions per kilometer traveled? Electric vehicle or IC engines? Anyone? Let me see the chat box if someone is answering in that. No. So what happens? CO2 emissions per kilometer traveled on an EV, it emits more emissions because electricity is directly coming from the fossil fuels. So converting that energy and the transportation of these increases the more pollution in the current energy mix. So there is a one important factor that we have to consider is energy mix of Indian electricity is having more of fossil fuels. So that's why it's a true statement. Like EV CO2 is more than the IC engine CO2. The only thing is like local emissions. Local emissions are negligible in case of EVs. But if you consider the its life cycle, then you can see it's emitting more CO2 emissions than the EVs in the current scenario. So there is one slide I think to go through this once, then you will, if you will see that graph by IEA, this one, is it visible? Yes. So carbon emissions of different powertrains by region. If you will see that region for the Indian region, then yes, here you will see. So EVs are related to the blue dots, and the IC is for the red dots. So currently ICE engines are producing around 150 grams of CO2 per kilometer traveled, and the future transition, like in the 2030, it can drop down to 100. And if we'll see the EVs are currently more than like 150. In the future modification, the energy mix changes, it can drop down to less than 100. So currently it's not that efficient, but in future it may be less CO2 emitting. So the relative carbon footprint of IC engine versus cars strongly depends on the power sector mixes. So Indian scenarios, it is less. In the European, when the most of the power generation is from the renewables. So for the Europeans and for the United States, uh, it's emitting lower CO2 than compared to the ICs. But for India and China, like more the developing countries, it's currently higher. I hope it is clear. Let's move to back to the questions. If you have any doubts, you can ask. Question number 4. High penetration of solar PV in the electricity grid does not affect on the power systems operations. What should anyone want to try? High penetration of the solar PV in the electricity grid does not affect the power systems operation. Is it true or false?
So false.
Can you explain?
Sir, because with the integration of this renewable energy, this will be more erratic in nature as per their load, because that throughout the day it is intermittent type load. So we can't have the same load throughout the time, throughout the day. Sometime it will be higher, sometime it will be lower. So it will be more difficult to integrate this renewable.
Correct. So yes, that whatever you said is right. I don't find the explanation of this. I think I missed it somewhere in between. Okay. So what should be the option? Yes, it should be.
It should be a definite effect on power system.
It does not affect our power system. Is it affecting or not?
It is very much affecting, sir.
Correct. So the statement is false. Okay, let's move ahead. I'll come back to this question. Okay. Now, figure 5, question number 5. Figure below shows the projection of average hourly electricity demand for India and European Union as a World Energy Outlook 2019 report. The fluctuation in the electricity demand during the midday in 2040 for a sustainable development scenario is higher in India than the European Union because of. So if you can see, so this gray line shows the 2018, that is the current scenario, because that report is in the 2019. So that's showing the current scenarios. This one, and blue line shows the 2040 stated policies. Green one shows the sustainable development. So it's asking the fluctuation in the electricity demand of midday in 2040 for sustainable development is higher. in India, if you can see here that sustainable development is higher in India 2040 than the European Union because of a large number of renewable power system in the grid during the sunshine hour, a stringent capacity addition targets, supply demand mismatch, or none of the above. What should be the so if you'll see uh, in India, a large number of renewable power systems in the grid during the sunshine hour because the peak in the electricity demand during the midday in the year 2040, like if you see in the peak, so this is the peak, and here if you'll see in the midday it's higher, so it's higher for the India, uh, can be attributed to the increase in the penetration of the renewable, specifically that if that solar power in the electricity grid. So that would be, if you go through this slides again, you will see more clear picture. This is covered in the this one. So this was the case. So daily variation in the CO2 average intensity is the factor of India, and in with the generation oscillating between the solar PV and the gas or coal. The European Union with the higher share of wind generation, so that is the reason of this peak will be solar power generation during the peak hour. This is a 12th hour, and that at that time the solar power will be the maximum as compared to the Europe, because they are mostly rely on the wind power. I hope it's clear. Now moving to question number 6. If we observe the fuel used by quintile in any nation, the percentage of electricity mix in the fuel users is least in the highest quintile, or we can say high income group. This is true or false? So the percentage of electricity mix is highest in highest quintile. So in that case, electricity mixes will be highest in the highest quintile, and then as the income level increases, as the income level increases, or we can just write it, income level increases, then the percentage of electricity in the fuel mix increases. That's why it should be the false statement, because it's saying it should be the fuel usage is least. That statement will be false. Anyone having any doubt? The question number 7. As the load factor increases, the cost of electricity generation will increase or decrease, or it remains same. Load factor is the plant load factor. It's also called PLF. It's ranges between around 60 to 100% in the various of the power plants. And the case of solar power plant, it ranges around 20 to 30% because of the availability of that sunlight during the daytime or the non-availability in the night time and the monsoon seasons. So plant load factor increases, that the cost of electricity generation decreases because we can generate more and more power in that case. Is it clear?
Once again, sir, please
Suppose
explain
plant,
again.
yeah, plant load factor is a thing like if you are having a power plant of 100 megawatt and plant load factor says that it can generate only it is generating only 60 percent of the load. So when the plant if if it is rated as 100 megawatt and it is operating at 60% of plant load factor, then it's generating only maximum of 60 megawatt. But in case in that case, all the other cost will remain constant, like operation maintenance cost and the capital cost will only the fuel cost will be decreasing, but other cost will be the same. In that case, cost of electricity generation will be suppose X, and when the 100% consider the plant load factor of the increases to the 90%, and all other costs will remain same, only fuel cost will increase. Then the per megawatt generation cost, like it can we can call it the electricity generation cost, will be lower in that case of higher plant load factor. Is it
Okay,
clear?
okay, sir. Okay.
Moving to the question number 8. It says which of the following are methods to increase the load factor for a microgrid so that the cost of electricity decreases. So now they're already claiming to increase the plant load factor of a microgrid, the cost of electricity decrease. What should we can do? First, they're telling industrial load, telecom tower, cold storage facility, or all of the above. To increase the load factor, it should be the suppose there's a microgrid and we have to increase the load factor so that the overall cost of electricity will be decreased. So we can vary the industrial load, we can vary the load of the telecom tower, we can vary the load of the cold storage. Why these three is considered? They are uh, energy, electricity intensive industries. So that variation in these loads will vary the uh, load factor of a power plant. So that means all of the will be the right answer. Is it clear? Okay. Now moving to the question number 9. According to the stated policies scenarios from World Economic Outlook 2019, demand of coal in India will decrease till 2000. Demand of coal in India will decrease in year 2040. Demand of oil in USA will increase until 2040. CO2 intensity of electricity generation for European Union will decrease in 2040. For CO2 intensity of electricity generation for China will increase in the year 2040. So it's a question from the slide. If you have gone through the slides, could have answered this. So the answer of this, the CO2 intensity of the electricity generation for European Union will decrease till the year 2040. 40. You can visit the slides in the case of WEO to get some more insights about this, because all the things you have to consider over the graph, where it is going, where it is not. CO2 intensity for daily life. You can see, have that slide here. Yeah, here you can see it's asking. First option was demand of coal, demand of like CO2 intensity of electric generation of the European in the 2040. You will see this. Stated policies here. If you will, yes, here you will see for the India, for the European Union, it would in the year 2040 it will CO2 intensity will decrease. So that will be the correct option. Now moving to the final question. It said, oh, what is likely disadvantage of high penetration of solar PV in Indian power sector? One is the ramping rate requirement of thermal generators will become high. Storage system will have to extensively employed. Option A and B or none of the above. What should be the? It's asking the disadvantage of high penetration of the solar PV.
A and B.
A and B. A and B will be the right answer, because due to penetration of the solar PV, due to solar PV, the intermittency of power generation will increase, because solar is an intermittent power. That means in the daytime, when the generation from the solar PV will be at peak and the load is less, then the generation of the storage systems such as batteries are required. So that means storage system will have to be extensively employed. And in the evening, when the load decreases and the generation from the solar decreases sharply, the generation from the thermal power plant has to be increased very rapidly. Thus, in the ramping rate requirement becomes high. That means question option number 1 will also be true. So that means option number C, A and B will be right. Is there any doubt in this question? Extensive storage system and evening time this is the explanation of this. Anyone having any doubt in the previous 10 questions, you can ask, because
Sir, please go to the question number 1, sir.
question number 1, yes. According to a different target set under the PAT scheme, the efficient plant have had a higher target compared to the similar plant which was more efficient. Yes.
So suppose the efficient plant say A, and that
Mm,
similar plant which was more efficient, suppose that is plant
mm.
B. So if plant A is efficient and B is more efficient, then the B plant is more efficient, na sir?
Yes.
So whether you call that efficient plant is less efficient compare with that which is more efficient and more
So
efficient.
I think you're confused. It's asking the efficient plant had a higher target compared to the similar plant which was more efficient. Suppose if a plant is more efficient, then it can generate more power with the its less targets as compared to the higher targets with the less efficient plants. Suppose a plant is having 80% of efficiency, it's having a target of 100 megawatt, and one plant is 60% efficient, and it's also having a target of 100 megawatt. In which case the target would be higher, the less efficient or the more efficient? Are you getting it?
So, sir,
So it is to
no,
encourage, suppose a plant is having less energy efficient, so its target would be set higher to increase the energy efficiency.
yes. So
Okay.
inefficient, sir, if we say that inefficient plant has higher than the more efficient plant, na sir?
Yeah,
In
it's
other,
asking about the targets. It's not saying the inefficient plant is higher efficient than the more efficient. It's asking about the targets. The targets would be set higher for the inefficient plant to so that they can increase the energy efficiency in that to generate more economical viability.
sir, whether I am right, sir, it is inefficient plant has higher target than more efficient plant.
Correct.
Yes.
So someone is asking in the comment section, sir, can you please provide us the problem solving session notes? Yeah, these are notes of all the classes are already uploaded in the uh, folder that has been shared with you.
Sure.
I think every week you got a mail of energy, like what is the chances or what is the live classes. If you're not getting it, I just show you where it is. If you go through the course, I will show you from the beginning. This is our course. When you sign in using your account, suppose in my case, I will. Okay, yeah, this is the course. So in that case, like in the previous recording sheet will be provided. Like, whenever the server link came, or so when you go to the recording sheet, there's a one link opens. Here you can find the YouTube links of all the week's recordings. Here you can find the presentation folder. When you open this, there is these things open. So here are from week 1 to week 11, all the slides are uploaded. If you want to access the slide of week 10, you just go through this, all the live sessions slides will be there. Apart from that, I've also sent a mail. Yeah, this one, the weekly video links and the presentation folder. You can find this in the announcement section. All the folder links and the week links are provided here itself. And I think you got the mail also. Okay, okay, fine.
Sir, also for the preparation, do
Yes.
uh, only MCQ type questions will be coming, or there will be more long answer questions also?
No, there will be a format. I think if you attended the session, they have explained. There will be 30 multiple choice questions. I will write it here. So that, wait. Yes, there. I'm writing here exam pattern. So exam pattern will be 30 MCQs having 2 marks each, and there will be eight numerical answer type or long questions numerical of having 5 marks each. So that would be constituted around 100 marks, and there will be 38 questions will be there.
So these numerical questions, we'll have to write the method, or we'll just have to mark the answer.
You have to mark the answers, and in the some of the questions, I think you have to write the some steps.
All right. And another thing, sir, I have three exams consecutively. So are there any important topics that are there in this subject?
No, the question paper is set by the sir only, so we don't have any access of what the questions are there from topics. So I
Okay.
think whatever the
If you,
topics that has been covered in the quizzes or the revision papers. So you might we should prepare that question first, or whatever the like questions will be similar like quizzes and the revision papers. So there are two revision papers that Sal solved in by himself. You can go through these videos, so that would give you the fair idea about the exams.
Sir, do you have the previous year question paper?
Oh no, we don't have that.
Sir, what you said
the
about revision
question,
paper?
yeah,
Yeah, one by
where
one,
are the
please.
revision paper?
Yeah, there are the revision papers. So that previous year questions will be similar in that case only.
Yes, so I'm asking where we can find the revision.
Revision papers, there are revision papers. So I think I've shown you in the today's class itself. If you go through the lecture number, this one, lecture number 25A, or we can say video number of that will be around 54. If you go to the NPTEL, that video number 54 and 55 will be the revision paper. So these thing, all the things, questions like 1, 2, I think Salas on 3, 4, and these 4 questions and solved in the detail. So if you want the links of this, so when you go through this, I've just bookmarked it. So this is the lecture videos. So revision paper 1, revision paper 2 consists of the lecture videos 54 and 55, and revision paper 1, there's lecture number, yes, yeah, lecture number 35 and 36. So these two things you must visit for the exams and all the quizzes, and whatever the theory parts you can already covered in that. I think like
Revision
whatever the
one
yes,
is revision paper one is lecture number 35, 36.
correct.
And revision paper 2 is 54 and 55.
Yes. And 31 also. 31 is a brief description about the questions only. Only 31, 36 are that. So it's just 8 minutes video.
Sir,
Uh,
assignment question will be sufficient for theory question.
yes, I think so. Because all the questions or whatever the theory parts has been covered by the sir. And then the question paper will be similar like that quizzes only. Quizzes and whatever the I have taken the classes of book problems solved in the question. These are the previous year questions only. So if you go through this problem solving session, you can able to solve all the numericals and theory questions itself.
Sir, one question is there. Sir, whether we have
Yes.
to calculate in written in some paper that for the numerical solve, or whether have to in separate sheet they provide separate sheet to for calculation. We have to write down and put down the right answer in that computer sheet from there.
Now, if there are long question type paper, then you have to write in the your sheet and submit that sheet. But if there's a question requires only few steps, then you have to you can directly write that into the computer itself. Physical calculators will not be allowed. Only on desktop calculators will be allowed in that case. So that questions will not be that much time consuming. Question paper would be much easier than you're thinking of. So don't worry about it. If you have just attended all the classes and gone through the videos, you're able to get good marks. Okay.
Okay, sir. Thank you, sir.
Is there anything else? Okay.
Sir, can you ask more questions about?
You can ask in the tomorrow session about anything about the exams, because I think I have something to teach today. We have 15 minutes left.
Okay, sir. Okay.
Okay. So I will start with the topic oil embargo of 1973. So in the 1973, there was a significant event that has impacted the global economy and Indian like energy landscape. Before that, nobody is much cares about the energy policies because there's no stringent policies to tell them. What is the cause? The Arab members of our Organization of the OPEC countries imposed an oil embargo on the export of embargo means sanctions. Several countries, including the US, Netherlands, Portugal, and South Africa. This action was retaliation for the support of Israel during the war. And the impact of this, the oil prices increases from $2.9 to $11.65 per barrel within a month. So that price hike caused the energy shortage in many countries, particularly those who are reliant on that imported oil. And the embargo triggered the global economic recession and exported the vulnerability of the countries heavily dependent on the foreign oil. So at that time, the long-term effect was the crisis spurred in a renewed focus of energy conservation and the deployment of the alternate energy sources. And the many countries has invested in the energy efficiencies measures and the power dynamics of the global. Like they have removed their dependency on the oil itself. There are a few additional points. Like in the March 1974, it's the embargo was lifted, but its effect was felt for the many more years. And this event highlighted the importance of energy security and the diversification of the energy sources for any country that is heavily dependent on the oil imports. So now we will start. What is the energy efficiency? If you have any want to ask any questions about this, you can ask. Otherwise, we'll start with the energy efficiency. So energy efficiency. So India's energy sector, there are a few key points like critical for growth. Energy infrastructure is essential for the India's economic development. It's diversified sources. India utilizes both conventional as well as the uh, renewable sources. Like most of the power generation is still we do by the coal only, and there are we are changing our energy mix to wind and solar also. Demand on the rise, energy consumption is rapidly increasing, and it is expected to continue grow. So energy efficiency is needed. Decoupling economic growth from the energy use requires improved efficiency. So progressive programs, India has implemented very few energy efficiency initiative like PAD, Perform, Achieve, or Trade, and Ujala. I will explain both of these schemes in the detail. So in the COVID-19 pandemic, it's slowed down the progress of energy efficiency a bit, but not fully. There has been few untapped potential of large scale efficiency improvement like are still possible across various sectors. So the benefit of energy efficiencies, it can reduce energy imports and need for new production capacities. We can whatever we have, if we can generate more efficiently in that itself, then we will not need any further import of oil, or we can or the implementation of any new plants. So this is the graph that is showing the energy intensity of per capita consumption trend. If you will see from the year 2012 to 2021, this is the per capita energy consumption. It's significantly increasing year by year. It's decreased in the 2020-21 due to the COVID-19, but it's still increasing on the year 20. This is the report of 22. So it's at the data only 2024. And this is the energy intensity. So if you can see, when the energy efficiency is increasing, the energy intensity is decreasing year by year. Now there are several schemes available in India. So with the different sectors, like if you say the industries large scale, we have the PAD scheme. For the MSME, we have the BEE SME scheme or ZB scheme. For the domestic, for the appliances, we have Ujala and the standards and labeling scheme. This is a SNL. For the buildings, we have ECBC codes or Eco Nivas. There are a few more schemes are there, and the agriculture star rated pumps for the transportation. There is a FAME scheme for the railways. For the similar for the buildings, there has been ECBCs and star rated building B, or we can also call them municipalities also MIPs there for the. So these are all the energy efficiency scheme that is available for the different sectors of Indian economy by the government of India. So it is estimated. This studies has been conducted. So estimated energy savings due to the energy efficiency. So adaptation of energy efficiency schemes or programs has led to an overall energy savings of around 44 million tons of oil equipment. That is the 6% of the total primary energy due to energy efficiency only. Now, adaptation of an energy efficiency scheme led to an overall thermal savings of around 23.85 megatons of that can save amount around 43,800 887 crores of Indian rupees. And electricity savings are, if you'll see that there are around 78.36 million tons of CO2 emissions we can save by implementing on the whatever the schemes that I've talked about. And now you get what is the effect of energy efficiency on the savings and CO2 emissions. Is there any doubt till now? Okay. So this slide shows a total energy savings by the schemes. So there are several schemes that has been mentioned here. So percentage share of the schemes and the overall savings are mentioned here. So majorly the major schemes is the PAT. So if you'll see the PAT scheme, so PAT scheme is covering around 54% of the share in the overall energy savings and then compared to the 4E and BW Ujala scheme, having some other schemes. So the total energy savings by the economics sectors in the year 21-22. So industries are having the major facts of that whole pie chart, and that considering around 23.24.36 percentage of the energy savings, and after that domestic standard and labeling programs or like Ujala schemes are contributing to the total energy savings. Moving ahead, this similar fashion, the CO2 emissions reduction by the economic sector majorly is coming from the uh, domestic schemes like standard leveling in the Ujala scheme that is reducing around 162 million tons of CO2 equivalent, followed by the industries and other schemes. Now there has been few impacts due to various energy efficiency measures. So you can see energy efficiencies in the from the blue column from the year 2011 to 2022. It's increasing from the and uh, actual consumption of the business as usual. So you can see the actual consumption is decreasing if we are if you are not implementing the energy efficiency measures, then there will be the graph would be higher. If you are implementing the energy efficiency measures, then our actual energy consumption will be lower than that of non-energy efficiency measures. So due to that, there are updated NDCs. NDC stands for the Nationally Determined Contributions for the Paris Agreement. That includes the reduce emission intensity of GDP by 45% of 2030. I think these are already covered in the class. I will just go through it quickly. Once again, achieve about 50% of the cumulative electric power installed capacity or non-fuel based energy sources by 2030, create an additional carbon sink of 2000 to 2.5 to 3 billion tons of CO2. Put forward further propagate a healthy or sustainable way of living. This is recently added. That's why it's called updated. And the lifestyle and the environment as a key combating climate change. To adopt a climate friendly and cleaner path for one followed heretofore by other corresponding level of economic development. So the questions can be framed from this topic can be like how what are the four options would be there, what is not the NDCs of the India to the Paris climate change. There will be one long answer, or there could be a, like what is not uh, NDC of a Paris climate of India. So in that way, I think we have solved this type of question in the class itself. Anyone facing any difficulty to go through with me in this lecture? You can ask in between if you're asking having any doubts. Now moving to the this is a chronograph of energy efficiency policies and programs in India. So first in the year 2002, there has been Energy Management Center. In the 2001, their Energy Conservation Act was established, and then in the year 2002, Bureau of Energy Efficiency, that is the BEE, is started, and energy professionals, followed by the standards and labeling programs, ECBC codes in the 2007, followed by the EC Act amendment, that's a Act amendment in the 2001, and the PAD scheme. PAD scheme is the most success schemes on the energy efficiency measures that was introduced in year 2012. And then also that few modification has been done the ECBC codes and the e-skirts trading, and the followed by the amendment of the energy conservation bill in the 2002. This was the most recent one because it's taken from the 2023 report. So that's how the whole life cycle journey of the energy efficiency policies has been taken through in India. So recent one is the energy conservation amendment bill. So energy conservation amendment bill having few changes has been done, like non-fossil fuel energy sources, carbon trading, energy conservation code for the buildings, that's ECBC codes, applicability for the to the residential buildings, standards for the vehicle and the vessels, regularity for the power of SERCs, that is the state electricity regulatory commissions, and the composition of the governing council of the BEE. So in more detail, you can just go through these slides again and you can find the whatever the details are there. So this is briefly what about the energy conservation amendment bill of 2022. Now, whatever the policy is made, how the policy is made, there has been a policy cycle. So policy cycle starts from the agenda setting, followed by the policy formulation, then legitimation, implementation, evaluation, and the policy maintenance. Suppose if you will see this energy EC Act was introduced in 2001. Then first it was agenda was set for that, then the policy was formulated, it was legitimatized, implemented, it is evaluated, and the policy maintenance and the succession. So it's modified many times, as you can see in the 2010 2022 also. So it's reevaluated, it's added, it's amended according to the need. So policy cycle starts from the agenda setting. So identify the problems, prioritizing the issues, then it's formulated. It's defining our goals, objective of the policy, choosing the policy instrument, evaluating the policy impacts, and the public participation. Then third thing is the adaptation. Adaptation, it's a selection of the best solution from the various proposals, obtaining approval from the legislative council like Lok Sabha or the Rajya Sabha, and the putting and then comes to the implementation part. Implementation start with the putting the policy into the action through the designated agencies, establishing the clear communication and the resource allocation, and the successful implementation requires strong political commitments. And final part is the evaluation. Evaluation starts from the assessing the policy's impact, its effectiveness, its difficulty arises due to multiple objective and measurement methods, and then policy maintenance, succession, or the determination. So after the evaluation, it's decided the policies need to maintained, it's need to be improvised, or it needs to be ended. So the deciding factor will maintain, modify, or the terminate. Modification addresses the problems identified during the evaluation. Example are Right to Education Act might be extended to cover the higher classes. So overall, if you will see the policy cycle is a framework for understanding the policy making. It simplifies the complex process for better analysis, and real world policy making can be more dynamic and fancy, as we can see. Any doubts about the policy cycles?
Sir, please,
Yeah.
saying something about carbon trading.
Yes. Can you please repeat?
Sir, please saying about something about carbon trading.
Yes. So what is your doubt?
Sir, what is carbon trading and how will affect the overall business scenario? Which whatever is
Carbon
coming under
trading is
this.
suppose what there is certain limits of CO2 that any industry or any process can emit. Suppose you are having less you're formulating a less CO2 emitting process, then you can save some of the CO2. So that CO2 emissions, you have to submit that report that you are saving this much of CO2 emissions. You will get a carbon certificate. Like suppose you are allowed to emit 100 tons of CO2 per year, but you have emitted only 80 tons. So 20 tons of certificate you will get. You can trade that certificate to the some inefficient industry that is emitting 120 uh, tons of CO2. So that's called carbon trading. So that's how carbon trading works. If you see, this is also in the like the bill employs the central government to specify carbon credit trading. Carbon credit implies a tradable permit to produce a specified amount of carbon emissions. The central government or any authority agency may issue the carbon credit certificate to entity registered under compliant with the scheme. The entities will be entitled to purchase or sell the carbon certificates. Is it clear?
Okay, sir.
So now we'll start with the PAT. PAT is a very successful scheme of Government of India that is maintained by the BEE, Bureau of Energy Efficiency. PAT means perform, achieve, and trade. So there will be some. So I'll start with the design of the PAT framework. That will be boundary setting, establishing the baseline, target setting, measurement, verification, and reporting, issue of requirement of ESG certificates, market mechanism of trading, and information of the compliance. So there are 5 industries they have started with. So there will be PAT stakeholders. Stakeholders will be Ministry of Power, and their responsibility will be policy making and the acting as a administrator. Bureau of Energy Efficiency will be nodal agency. Designated consumer will be implemented. State designated agency will be state administration. SERCs will be adjudicator, and there are few all other things you can follow. So there are till now there are 5 PAT cycles that has been implemented. So I will explain first 3: PAT 1, PAT 2, and PAT 3. PAT 1 started from the 2012 to 2030 and 14 to 15. Industries were aluminum, cement, chlor-alkali, fertilizer, iron, steel, paper pulp, and power plant and textiles. So in the PAT 2, railways, electricity, and TESCOMs are added in the PAT 2 and PAT 3. Number of uh, disease and the in this sector are increasing in the from the year by year, and the energy saving targets also. So in the PAT 1, energy saving targets are 6.86, and it's increased to around 1.06 for the 160. So if you compare this, it would be a very high number. So there are few results on the PAT cycle 1. If you see the sector wise energy savings, so you can see green one. Thermal power plants are the most like they have saved 35% of their energy is saved. Like most of the energy that has been like here it is meant 6.86, like 35% of that part. 3.06 is achieved by the power plant only, followed by the uh, iron, steel, and other industries. And the outcome of the PAT cycle one is energy savings around 55,635 megawatt, or 8.86 of uh, million tons of oil equivalent, or we can convert that into India's primary energy supply. That would be 1.25% of the total energy India's primary energy supply. And coming to the emission reduction, 1.93% of the total emissions are saved from the PAT1 cycle. And the capacity building, 50,000 plus engineers and certificate for the process industries. There are savings of around 9,500 crores. There are investment that has been done around 26,000 crores. So that is the outcome of the PAT cycle one. Coming to the PAT cycle two, there are few targets that has been set initially. So if you see, the targets are discoms and railways are added. So there has been few targets are set for these industries, and these are the targets achieved. So whatever the targets, if you see the thermal power plants, the target set was 4 point, if you will see the thermal power plant target set for 2.283. So it is achieved around 3.43. So that means it, so like whole methodology of PAT is perform, achieve, or trade, achieve. So it is overachieved. So its targets are overachieved. Now it can trade its achievement. So if you can see here, it was initially targeted only 2.8 2.28 in the thermal power plant. If you can see, like 3 point, sorry, this is 3.134, and it has achieved 3.43. So remaining of the its achievement, it can trade to the some other industries that are not able to perform. So that's how it works. Perform, achieve, or trade. Achievement is like whatever the targets is set for you, you will achieve. That will be the base case. If you're underachieving, you have to trade that from the industry that is overachieving. If you're an underachiever, so that's how whole cycle works. This is the results of the PAT 3 cycle. Here we have directly taken that what is the target set versus target achieved. So the aluminum industry, it is overachieved. In the cement industry is also overachieved. All the industries have achieved its targets very well in the PAT cycle 3. Yes. Is there any doubt in the PAT? You can ask. Any doubts till now? Okay. So I hope everything is clear till now. Now I will start with the next scheme, that is 4E scheme. 4E scheme stands for the end-to-end energy efficiency scheme. That's how it's called, 4E. So its objective was to implementation of the energy efficiency strategies. They are fulfilling the financials needed for the capital expenditure to provide the finances for the land and the type of the equipment, and the expenditure for any mentioned energy efficiency measures should not be more than 50% of the total project cost. So these are the four objectives of this scheme. So benefit of these schemes for the stakeholders are like 4E program helps to the MSME improve the bottom line through the energy savings of 10 to 25%. Back to back financial supports are given from the World Bank. There will be normal detailed energy audit, implementation of the support, 30,000 plus applicable for the taxes for the, these are the few things are mentioned. You can go through this. Areas covered under detailed energy audits are energy consuming equipment, and so these are all the stakeholder benefits for the stakeholders. You can go through this in the detail if you want. And so now coming to the next scheme is Ujala. Ujala was also a very successful scheme. So there are few outcomes of that Ujala scheme. Improving the people's quality of life. Ujala is reducing annual household electricity bills by 15% by saving the consumers over 16 billion rupees annually per year. It's increasing the it's having the high quality manufacturing. ESL, that is a providing agency for that LED bulbs, a high quality Indian LED lamps manufacturing in India. India is now the second largest LED market in the world. Third is the contributing to the climate target, saving scarce energy resourcing and cutting down India's CO2 emissions, carbon dioxide emissions by 3 million tons of CO2 per year. This equivalent to the power of power plant or removing 2.7 million tons of cars from the road per year. So that's a huge impact that Ujala scheme has impacted on the Indian energy sector. So there has been few one scheme in the automobile sector, that's FAME. FAME was a faster adaptation and the manufacturing of hybrid and electrical vehicle. So the focus areas are demand creation, pilot projects, terminology, technology platforms, and the charging infra. So achievements of the phase one of the FAME was the total incentive of 41% of the funds was allocated, was utilized. 2.8 lakhs of vehicles are sold, and there are few OEM. OEM stand for the original equipment manufacturer. That's in the phase one, like TVS, Hero, Ather. That's there are a few charging infra has been developed. So all the details are given here. You can go through this. But if you see, go through the timeline of FAME, FAME was started in the year 2013, and this was the first EV mission launched by the government National Electric Mobility Mission Plan (NEMMP) in the 2020. Was launched in the 2013, then followed by the scheme one, FAME 1 scheme, FAME 2 in the 2019, and the NEMP in 2020. Now in the 2022, there have been some few more plans in the FAME 4 that will be discussed in the that will yet to become. Now there are a few features of the FAME, like provision has been made in the scheme for the inter as well as the intra segment also. Scheme is also applicable primarily on the registered EV two-wheelers, applicable mainly to the vehicles used for the public transport. Generate demands of the on the public service. Demand incentive scheme is applicable only for those vehicles which are defined as a motor vehicle, and the incentives for the vehicle manufacturing, there's a incentives are given for the registration in the some states also. So this is the salient features of the FAME scheme. Now there are a few schemes that has been. If you have any doubt, you can ask about the few schemes that has covered FAME or the 4D scheme. Now moving to the schemes related to the buildings. So in the building sector, there are schemes for the building sector like guidelines, codes, or the standards. One is the ECBC code, Energy Conservation Building Codes for the commercial buildings, Eco Niva Samhita, or ENS tool or for the residential build labeling program focusing on the energy efficiency in the existing buildings. So these are for the new buildings. This is for the existing building. FAT scheme for the hotel buildings, nearly net zero energy building, Shunya labeling program, EHL, or BW star rating. And the rating system like Griha, uh, IGBC, GEM, or CPWD rating by GHAR. So there are a few rating schemes also. In the sector of agriculture, if you see the electricity consumption in the electricity sector in the gigawatt hour from the 2010 to 2022 is continuously increasing. So there should be some policy. So main info about the there are a few major initiatives that has been taken to promote the energy efficiency in the various field of agriculture, driving a national-wide awareness program for the farmer to promote the adaptation of the energy efficient pumps, because the major consumption of the agriculture is the pumps only to harvest the crops due to for the pumping. So energy efficient pumps were the one of the major initiative, organizing technical training program for the pump technician and the development of the mobile application, demonstration of IoT, Internet of Things, and the sensor-based climate smart agriculture initiatives, energy efficiency in the aquaculture of fisheries through the use of energy efficient aerators. So if you have any doubts in this, whatever the schemes that I have taught, you can ask. Okay, I hope everything is going. You're able to go through this. All the recordings will be available for that lecture if I'm going too fast, or you can go through these slides again. Whatever the data I'm presenting is data taken from the Bureau of Energy Efficiency report of 2021 and 22. You can go through this in the detail, whatever theory parts is all. These things are around having a report of 250 pages that I've summarized in this 20 to 30 slides. You can go through that if you want more details about this. So based on these schemes, I have formulated few questions. You can participate in that if you have attended these sessions thoroughly. You're able to answer. So question number one is, India's energy consumption has decreased significantly due to the recent energy efficiency programs, remained stagnant in the past decade, increased rapidly, and expected to continue growing, fluctuated based on the economic performances. What should be the answer? A, B, C, D. Okay. So the option answer for this will be increased rapidly and expected to continue growing. So that is the motivation for going to the energy efficiency programs, because our demand will be increasing, but to decrease the steepness of the demand, we should be apply the energy efficiency measures, so that we can grow through that rapidly but steadily. Now, second one is the perform, achieve, and trade scheme is designed to set minimum energy efficiency standard for the appliance, encourage industries to improve energy efficiency through targeted goals, promote the use of LED in the residential building, provide financial assistance for the renewable energy projects. This is a very straightforward question.
So it is B.
It's it's B, correct. So it's clearly telling PAD scheme is for encouraging industries to improve energy efficiency through the targeted goals. Now, moving to the question number 3, the Unnat Jyoti by affordable LEDs for all, that's called Ujala. A scheme primarily targets reducing energy consumption in the industrial facilities, promoting energy efficiency in the agriculture, making LED lights more accessible for the household, or upgrading the national power grid infrastructure.
It is C, sir.
Let's see, correct. Because Ujala scheme for the LEDs only. According to the passage, the COVID-19 pandemic likely accelerated the implementation of the energy efficiency program, had no significant impact on the energy efficiency initiative, increased public awareness of the need of energy conservation, or slowed down the progress of some energy efficiency programs.
It is D.
It's D, correct. This is also mentioned here. The yes, Here you can see pandemic impact COVID-19 has slowed down the progress of energy efficiency programs. Now, final. The passage suggests that the large scale implementation of the energy efficiency measures in India could lead to increased reliance on imported fossil fuels, reduced need of investment in the new power generation capacity, a decrease in the overall economic growth, or the and shift towards using nuclear power as a primary energy source. The large-scale implementation of energy efficiency measures in India could lead to reduced in
It is B, sir.
need of it's B, correct. B is the right answer. Very good. You have answered 4 out of 5 questions correctly. So I hope these things are clear. Now, last few slides about the future energy systems. So future energy systems can be focused like whatever the system we have studied till now. Apart from that, future energy systems can focus on integration and the efficiency. Like smart grids, these intelligent grids can integrate various renewable energy sources, optimize energy distribution, reduce energy waste, and demand side management. This involves the encouraging the consumers to like whatever the power we are generating, we should have a feedback loop. Like whatever the energy is generated, it should having a demand side management as well as the energy storage. Currently, most of the energy is being wasted due to the lack of energy storage, like solar power in solar power based infra is desperately needing an energy storage system. So energy storage will develop efficient, cost effective energy storage solutions, and that will improve the like advanced batteries will be crucial for storing that access renewable energy to make that grid more reliable and flexible. Other thing is the advanced technologies and renewable. Next generation renewable like exploring the promising renewable energy sources like advanced solar technologies, wind turbine designs, and the ocean could diversify the energy mix. Hydrogen energy, it's called a fuel of future. Developing a hydrogen economy where the hydrogen is produced from the renewable sources and used for the transportation of energy storage holds a great potential. The most important is carbon capture and the utilization. Like to decrease the emissions, the technologies that can capture carbon emissions from the power plant and utilize them for the industrial processes or storage could help them mitigate the climate change. The final thing is sustainability and the societal consideration. So that can be achieved by the energy efficiency to improving the energy efficiency in buildings, transportation, or the industries, distributed generation, encouraging the local generation through rooftop solar PVs, small wind and turbine, microgrids, and energy for all, ensuring everyone has access to affordable and clean energy is crucial for achieving sustainable development. So that's all for the this subject or this class. If you are having any doubts, you can ask. If you want to ask any doubts, otherwise we are done with this class.
Sir, what is carbon sequestration?
Carbon sequestration is the carbon absorption. Suppose you have captured the carbon from some processes, but what will you do with this carbon? Sequestration means suppose carbon is used to make a fuse, like whatever the petroleum or the natural gas you are getting it from the soil. So you will capture the carbon and you will sequester it. Sequester means you will dig a hole and dump that whole carbon that you have captured into the soil, and that carbon will somehow help to generate the fossil fuels. That's called carbon sequestration. or that can be used by the plants to generate their food or to their other measures.
It is same as carbon capturing.
Carbon capturing is like capturing is the first step. You will capture that carbon, but what will you do with that? Second thing, either to utilize. Utilize means you can utilize the CO2 into the cooling applications or into some other chemical industries. That's called utilization. So other thing is sequestration. If you don't have any use, then you have to sequester it. That's why it's called completely CCUS, carbon capture and utilization or sequestration. Its complete term is CCUS. I hope it is clear.
Sir,
Okay.
can you ask a question, sir? A specific question.
Yes.
Sir, is there in near future we can go for solar thermal tower technology in India?
Solar thermal. The solar thermal is going on already. Like if you go through that, that's a different subject of study. Means if you have to go through in very detail, if you want like whatever the in the brief, yes, it's possible. Okay, if you don't have any other doubt, you can just end up this session. Good luck for your exams. We will have one more quick sessions for the tomorrow in which you can ask the whatever the queries you have about the whole subject or any doubts about the exams. Okay.
Thank you, sir.
Thank you. Thank you for the
And
attention.
thanks for your all classes, sir.
Oh, that's my duty.
Thanks.
Okay.